Okay, so chapter 3, we're going to look at some of the basic skills first. So solving simultaneous equations by elimination. Now this is a skill which most of the time you won't need. Most of the time you'll be solving simultaneous equations using your calculator. I'll show you how to do that in a second. But it is a skill that you are expected to know. So if, for example, something comes up with algebra in it rather than just letters, then you can be expected to be able to solve simultaneous equations. It's actually one of the things that happens quite a lot, especially with graphs and stuff later on with other more difficult concepts. So the idea is useful. You won't necessarily be asked to just solve simultaneous equations, but the ideas of solving or simplifying something by eliminating one of the variables is very common. So I'll just do A. In this case, what I would do is probably to double the top one. You may triple the top one and then add them together. I'm going to double the top one and subtract it from the bottom. So 2x minus y equals 6 doubles to 4x minus 2y equals 12. And then I've got my other equation. I'm going to find the difference between those. So the difference is the bottom one has 5 more y and 10 more on that side. So that means y equals 2. You then substitute that back into one of the equations. The top one seems the most simple. So 2x minus 2 equals 6, which means 2x is 8 and x is 4. So relatively simple as an idea, GCSE idea. If you were given equations in this form, you wouldn't normally get many marks for solving them, maybe 1. And as such, I would probably do that with your calculator. So I'll go out just in case you didn't see that. Equation, then simultaneous equation, 2 unknowns, and you can't change the letters here. So if your letters aren't x and y, you just have to remember which one you've inputted as x and which one you've inputted as y. But then you just press equals at the end, or execute it is now. X equals 4, y equals 2. So you can check the rest of those. That is a skill that comes in very handy, as I say, with more complex topics. Another one which is very useful for more complex topics is the idea of solving by substitution, or just simplifying something by substituting. So what I'll do for the first one is make x the subject, so that's 11 minus 3y, and then substitute x into this one. So 4 lots of 11 minus 3y minus 7y equals 6. And by doing that, you've eliminated or removed the x from this equation, and now everything is in terms of y. It's a linear equation now in terms of y, which is hopefully easy enough to solve. So expand the brackets, put the numbers on the other side. So minus 38, so y equals 2. And then same idea as before, once you've found one of them, you can find the other by substitution. So x plus 3 2's equals 11, so x is 5. Now, again, it says to do it by substitution, so it's just you practicing using those skills. You can answer those with the same simultaneous equation button on the calculator. Ones that you can't solve on a calculator, and so really the only way to solve them is by solving them simultaneously, like manually, without using a calculator. Questions like this. And for this first one, I would say that what I'm going to do, instead of making, say, x the subject or y the subject, which would be maybe what you'd expect to see, you do x equals 7 minus 2y all divided by 2. The reason I'm not going to do that is because I don't particularly like having fractions. I will avoid them if I can. So what I'm actually going to do is make 2y the subject. that's just 7 minus 2x. Because when I square that, I get 4y squared. And this is one of the things with solving simultaneous equations that you want to keep in mind. You don't just have to substitute an individual letter. You can substitute a term, so 4y squared, or an expression, so long as what you're substituting it with is equal. So here we know that 4y squared is equal to 7 minus 2x all squared. So you can just substitute that, x squared minus this, 7 minus 2x squared equals 8. And now we have a quadratic equation, but only in x. So we can solve that. Expand the brackets. Be careful with this. I'm going to keep it in a set of brackets, expand it, and then do the subtraction. If you try and do this all in one step, a lot of the time there will be some kind of sign error. So 7 squared, 2 times 7 times 2 is minus 28. And then plus 4x squared equals 8. And then do the subtraction. That way, what we're doing, x squared take away 4x squared, let's say, minus 3x squared. And then minus 28x, so plus 28x, minus 49, minus 8, so that's 57. From there, unless it expressly forbids it, I would just use my calculator to solve that quadratic, minus 57. If it comes out to be a fraction like this, I'm just going to pretend I solved it, or factorised it myself, sorry. So 3x minus 19, x minus 3. Wait a second. Oh, I need a minus up front. Equals 0. What I noticed there was 19 times 3, negative 19 times negative 3 makes negative 27, but it's because it's got a leading coefficient of minus 3. I can just get rid of that minus because it's equal to 0, but it's something that you should notice. So I've got my values of x, 19 over 3 or 3. Substitute that in to the y equation, whichever one you want. I'm going to use just the simplest one, the first one. So 7 minus 2 lots of 19 over 3 is negative 17 over 3. That's 2y, so I just halved that. And then this one's much easier. It's 1, so half of that is a half. Right. If at all you want to check these are correct, then you can do that with any solving equation. You can just put the values you get back into the original equations. So if I want to check these ones because I think they're a bit weird looking and you're not expecting to have fractions or negatives, or you just want to check to see if you've got the right answer so you can move on knowing that you've got it right, you can do that. Substitute it back into the equation. So 2x's plus 2y's should equal 7, and x squared, so 19 over 3 squared, minus 4 lots of negative 17 over 6 squared should equal 8. So if it does, that means that you've got the right solution. So yes, that's what I'd say. One of the main points here was I made 2y the subject so that I could square it. It avoided any kind of fractions. Fractions, I know I can make mistakes, so I just try and avoid them where possible, and if I do have to put fractions in, I pay careful attention. For this one, I would make x the subject, so x equals 9 minus y, and then substitute that in for everywhere it says x, it would work just as well to make y the subject. Here, it's not so easy. Notice that there's an x squared and an x, and there's only one y, so maybe I would make y the subject and put that in here. It avoids unnecessary substitution where errors can be made, but make y the subject. That one would have to have fractions in, and so I just have to be careful when dealing with that. For a question like this, determine the number of points of intersection of a pair of simultaneous equations, all you're looking for is you can plot one, or sketch one I should say, and then sketch the other on the same axes. So you need to have some kind of understanding of scale, and then sketch them both. And you're just looking for how many times they cross. So if I had a quadratic as one of them, probably I would just use the calculator to find all the pertinent information. So that is where it crosses the axes, which is positive 0.86 and negative 1.36. It's going to cross the y-axis at -7, and this will also tell me where the turning point is, but in this case I don't think that's going to be important. So let's sketch that. So by sketch I mean it's not to scale. It's a pretty good scale, like it's not terribly out of scale, but do notice that here I've got -7, whereas -7 on this axis would be way to the side. So that's the top equation. The second one is going to go through the y-axis at 8, and then it's going to go through the x-axis at -4, which on the scale that I've got would be way over here somewhere. So -4, straight line. Did quite well there. And then we're looking for just the number of points of intersection. So in this case, 2. There's going to be 2 solutions to these simultaneous equations. Do the same thing with the other ones. You're looking for whether it's going to cross it twice. If this said instead of +8, it said -8, then it might miss it completely, in which case there would be 0 points of intersection and 0 real solutions. The other way of solving that would be to make them equal to each other and then put the discriminant. The discriminant would be greater than 0 for these, or less than 0 if there were no solutions, or equal to 0. So a lot of these things will have multiple uses. You've just got to select the one that either the question talks about or the one that you're most happy with. Okay, linear inequalities. Starting off very simply with 2x minus 3 is less than 5. So just add 3 to both sides, divide by 2. The only thing I would be careful with these would be, say, question I has got a negative x, so if you were to do it in the same way, so take away 5 minus 4 and then divide by -1/2, you have to, in that case, flip the sign. So anytime you multiply or divide by a negative, you have to flip the inequality sign. Okay, moving on to the intermediate questions. We have sketching or finding the set of values of x for which this is true. This is a quadratic inequality. What I would recommend with these, move everything to one side so it looks like a quadratic. Solve this like as if it was equal to 0. So this one factorizes x plus 5 x minus 2. And if this was equal to 0, you'd be able to solve that. You'd know that the x coordinates where it is equal to 0 where x is minus 5 and x is 2. So if you just draw a tiny sketch, 2 and minus 5, it doesn't have to be brilliant, but or even large. What you're doing is you're selecting the bit which is less than 0. So on a graph, the outcome of this being less than 0 is the y coordinate is less than 0. So we don't care about any of that or that. We want the bit between minus 5 and 2. And so the set of values for x would be less than 2 and greater than minus 5. If this says less than or equal to, this would be less than or equal to. If it says greater than, you're looking for the bit that's above. Now for this question C, that's negative leading coefficient, because when you expand that you're going to get minus 2x squared, which means it's still going to be between the two values. But if you imagine for the first question it said x squared is greater than 10 minus 3x, you'd do exactly the same, but you'd end up with x plus 5, x minus 2 is greater than 0. Instead of the bit underneath the graph, which is between the two values, you'd want the bit which is above the graph. So that would lead to x being less than negative 5 or x being greater than 2. So when it's between, you can just write it as a single inequality. If it's above, there's two separate sections, so it needs to be written as two separate inequalities. For a question like this, given that x is not equal to 0, find the set of values of x for which 2 over x is less than 1. You'll be very careful, because when you multiply by x, a lot of people, I'll see them do this, go 2 over x is less than 1, and then they'll go straight to 2 is less than x. Now, that's okay so long as the x is positive, but remember when you do inequalities, the x, if you're multiplying or dividing by something which is negative, then the sign flips. So actually that's problematic, because when x is, if x is negative, then when you multiply by it, the sign flips over. The easiest way I would recommend to do that is to sketch the graph of y equals 2 to the x, or not 2 to the x, 2 over x, which would just look like any other reciprocal graph. But that doesn't turn around. Then the other graph of y equals 1, which would just be a horizontal line going through 1. Find the point where they intersect by solving it. That would be x equals 2. And you're looking for anywhere where the curve is less than 1. So there's two places. Here, so where x is greater than 2, that's the one we found. But also any negative value of x. They all are underneath 1. Okay, so I would recommend sketching the graphs for that one. The alternative, if you really, really don't want to sketch, is when you're doing this first step, you have to split it into 2. Okay, so you have to consider x being positive and x being negative. Right, so the x being positive is the easy one. That's just 2 times by x, so less than x, which means x greater than 2. This one, you still times by the x, you get 2 and x, but because you're timesing by a negative number, you flip the sign. This is x is less than 2, but because you've already said x is less than 0, you combine these two together. If x is less than 0 and it's less than 2, that means that it's less than 0. So this is the more restrictive, and that's where the other x is less than 0 comes from. You still end up with the same information, So you get for positive values of x, x is greater than 2, and for negative values of x, x is less than 2. But if it's negative, it has to be less than 0. So x is less than 0. If you understand that, fabulous. I would still recommend drawing a graph or sketching a graph so that you can easily see, it's just literally what's underneath the graph. What's underneath the y equals 1 line. For these questions around regions, we've got y is greater than x minus 2. So remember, for a region, if it's a greater than or less than, you draw a dotted line. For if it's greater than or equal to or less than or equal to, then that is a solid line. Y is greater than x minus 2 is, I would just plot the line y equals x minus 2, but dotted. I say plot, sketch. And then consider which side you want. So you want y is greater than x minus 2. Now if you just pick a point on one side and then just determine whether that is or is not satisfying the equation or the inequality. So if I choose just the origin, because that's on one side of the line, 0, is that greater than 0 minus 2? Yes, which means that this side of the line is what I want and this side of the line is what I don't want. Okay, so y is greater than, that's the bit above that dotted line. I'm going to have to keep that in my head. Y is less than 4x, so again I'm going to draw a y equals 4x, and I want this time y to be less than 4x. So if I was to choose something like 1, 1, which would be around here, is 1 less than 4x, or 4 ones? Yes, so I want what's underneath that line. So far I've got above this dotted line and below this dotted line. The last one, y is less than or equal to, so a solid line, 5 minus x. I'm going to draw y equals minus x plus 5. So put 5 in as a solid line. And I want y to be less than, so that's going to be underneath that line. So the region is going to be this region. If you then choose just to choose something, if you've drawn a relatively good picture, you can find a sketch. You can just choose, say, the point 1, 1, which you expect to be inside the region. You just check that 1, 1 against each of the inequalities. So is 1 more than 1 minus 2? Yes. Is 1 less than 4? Yes. And is 1 less than or equal to 5 minus 1? Yes. So this is the correct region. Moving on to the advanced questions. For here we are asked to sketch the graphs of the two functions on the same axes, find the coordinates of any points that intersect by solving them simultaneously, and then write down the solutions of the inequalities where f of x is less than g of x. So let's just go with that. Sketch, so 3x minus 7 is going to go through minus 7 and have a gradient of 3. So that's y equals f of x. It's going to go through 7 over 3. Next one, 13 minus 2x. So it goes through 13 and has a gradient of minus 2. So it's going to go through 13 over 2, 6.5. Not the greatest picture in the world. Sketch. I should stop calling them pictures. So that's the sketch. Find the coordinates of any points of intersection. So finding the intersections of two graphs is as simple as solving them simultaneously. So 3x minus 7 equals 13 13 minus 2x. Add 2x, add 7, find the, sorry you can't see what I'm doing, find the x coordinate, substitute that back in to find the y coordinate, so y is equal to 3x minus 7, so that's 5. If you want to check that, simultaneous equation, if it's two straight lines, no problem. You just have to write it in the format that's written here. So that would be 3x. We're plotting y, so that would be minus y equals 7. And then minus 2x minus y equals minus 13. So x equals 4, y equals 5. That's II. Write down the solutions to the inequality of f of x is less than or equal to g of x. So this one is g of x. Of x. If we want f of x, which is this line, to be less than g of x, which is this line, we're looking for all of the points where this line is below this line, which is from that intersection leftwards. Okay, if you go right, then f of x is above g of x, and if you go to the left of that intersection, g of x is above f of x. So the solution, you don't have to do any more working out other than looking at the graph. The solution to that inequality would be x is less than 4. Just simply because that is 4, and when it's less than 4 on the axis, then the f of x is below the g of x. So less than or equal to 4, because the equation says f of x is less than or equal to g of x. So the equal to is at 4, and then anything less than that is less. Okay, so plot them, find the intersection points, and then just look at the graph to see. You want the f of x graph to be lower than the g of x. Maybe do one of them in one colour, one of them in another colour, make it easier to see. From then it just moves on to the exam questions. So I'm just going to quickly look through, see if there's anything of any particular difficulty. Solving simultaneous equations in multiple ways. They're always by substitution, normally involving quadratics. This one says by elimination, show that this is true, and then the second part is going to be solving, starting by solving that equation, the quadratic one. Again, we're going to do the first step of simultaneous equations ending with here. Then it brings in this equal roots thing, which means that the discriminant is equal to 0. You use that to find k, because this is a quadratic. B squared minus 4ac equals 0, find k, and then use that to solve. Then it comes on to the questions which are inequalities. So it says mixed, basic and intermediate, because the first question here is basic, it's just solving a linear inequality. Then an intermediate question, which would be solving a quadratic inequality. For them both to be true, you're looking for the most restrictive of the inequalities. So if something says it's got to be less than 4, and then another one says it's got to be less than 3, then go with less than 3, because that's true for both of them, not just for one. A few of that same ilk. Moving on to this question, you'll see maybe a lot of these, or a few of them will have this, two distinct real solutions. That comes back to chapter 2 with the discriminant being equal to, less than or greater than 0. If it's got two distinct real solutions, the discriminant is greater than 0. So that's what you're going to start with. And then solving for the possible values of k, this has got to be probably greater than 0, but I'd have to do that equation, or do that question to guess that. I'm guessing there's going to be some kind of inequality there, so that you can get a set of possible values. And I think a lot of the other ones are going to be similar. So, yep, lots of questions which also use quadratics. So you'll see that quadratics is quite an important topic because it brings in other topics all the time. Or it's like you think you're doing something which isn't quadratic and then suddenly it is quadratic. I mean, this one seems to be obviously quadratic from the beginning. Maybe I'll just show you this one because a lot of the other ones are similar to this. So, two distinct real roots means the discriminant is greater than 0. It's positive. So the discriminant you get by doing b squared, so this is b, minus 4 lots of a, which is 1 times c, which is that. And we know that the discriminant, which is b squared minus 4ac, is greater than 0. So if I expand this, I should end up with that. Expand and simplify, I should say. So minus 6k plus 9 minus 4 times 3, which is not 4, it's 12. And then minus 4 times minus 2k is plus 8k. So plus 2k minus 3. And good, that's what it says. For part B, find the possible set, or the set of possible values for k. It's solving an inequality, which is quadratic. Forget the original quadratic, now you've got this k quadratic. Solve it. So, I mean, you can do this without, this is k minus 1, k plus 3. So, I'm going to get 1 and minus 3. This isn't an x squared, it's k squared. But it's not something to really worry about. That's 1, that's minus 3. You just are looking for, what's greater than 0. So that's not the bit underneath, but the bit above the axis. So k is greater than 1, or k is less than minus 3. Things to check is, does it say greater than or equal to? I mean, in these cases where it's come from a discriminant, it's never going to say or equal to, unless I suppose it says it has real solutions. If it doesn't say it has two distinct real solutions, if it just says it has real solutions, so that's greater than or equal to 0. And that is that. Thank you.